And welcome everybody to the Daily Space Weather. We're looking at the newest sunspot on the closest star. You can see some minor flaring coming out of that sunspot. It is beta class. By the way, I'm your host, Dan, aka smAsho. And thanks everybody for tuning in. And congratulations on finding the channel. This is 94 angstroms, by the way, from the Solar Dynamics Observatory. And here's the other sunspot group. These are both beta-class sunspots, folks, and there is still continuing possibility for significant solar flares. Great view of the northwest. Here's a full disk view in 304 angstroms. This is ionized helium. The last one was ionized iron. And here's another ionized iron wavelength, 171 angstroms. All of these images are from the Solar Dynamics Observatory. And it looks like another active region rising up here in the northeast. Here's a diagram of the solar system. Here's where stuff is now. There's where things will be in a week. It looks like new moon will fall on June 10th, my favorite phase of the moon. Here is a star chart, and you may see the moon and Jupiter and Saturn near the ecliptic if you're up before dawn. The 10.7 centimeter radio flux, the radio output of the upper chromosphere and lower corona, currently at 76 solar flux units. Here's a one-year chart of that. To put it in context, this black line is the radio flux, the red line is the sunspot number. No forecast by NOAA for any solar storms or geomagnetic unrest or anything like that. And we've only seen minor B-class flaring over the past 24 hours. Let's take a look at earthquakes and volcanoes. First, earthquakes. Here's the 90-day bar graph of major earthquakes on planet Earth. And we've seen quite a few 4+ magnitude quakes over the past 24 hours here. Quite a few 4+ magnitudes. Perhaps some of those may be foreshocks. But in any case, here are the 5+ magnitude quakes. Only 2 of those showing up on that map. Let's run up the USGS list. And we're seeing some quakes in the Middle East here, as well as some deep quakes in places like Japan. There's one at the Philippines. Here's one at 10 kilometers above sea level, allegedly. Somehow I doubt that's actually correct. Let's check the location of that. 10 kilometers above sea level, above the ocean. Boy, that's an awfully interesting earthquake, isn't it? 10,000 meters above a section of ocean is where that earthquake was reported to be. It was only a 2.6 magnitude. I won't get into how that happens on this video. Perhaps we'll do a video just about that at a later time. Extremely deep quake here near Fiji, a 4.9 magnitude at over 600 kilometers depth. Also another deep quake there at 577 kilometers depth. Extremely shallow quake at Hawaii. Let's see if that's a little more logical. Near the town of Volcano. What a creative name. And this one is under the main calderas of Kilauea at 1,100 meters above sea level. So that's likely magmatic. Here's another deep quake at the Philippines. So quite a few deep quakes, some at significant depth, as well as some significantly shallow depth. Let's check volcanoes. Semeru on East Java has been exploding, producing a 14,000-foot ash plume. Fuego, 15,000-foot ash plume at Guatemala as it explodes as well. Sangay in Ecuador exploding. 20,000-foot ash plume above it. Please don't fly your hang glider over the caldera. Sabancaya exploding. continuous emissions of ash have produced a 24,000-foot plume of ash. Nevado State Chilean exploding. In central Chile, 14,000-foot ash plume there. And Nyiragongo continuing to explode. Not good news for the town of Goma. A volcanic ash plume estimated to rise to 18,000 feet of altitude. Is a great reminder to not pole vault the caldera. So please don't pole vault the caldera, folks. We implore you. No matter how athletic you are, no matter how much of a track and field star you are or were in the past, please do not pole vault the caldera. This public service message brought to you at massive personal risk and expense from smAshomash.com. Next, back to space weather. The GOES X-ray flux showing only one significant solar flare here over the past 24. Its peak flux was right at 2 o'clock, 2 a.m. Universal Time here on today, June 3rd. No spikes in the proton flux, no surprises there. We would have probably forecasted it. Here's the GOES magnetometer over the past 3 days, and we're seeing very low levels here of GOES magnetometer. And there is some plasma between Earth and Sun once again. And here's some imagery of that. And let me just show the last image. This bunched up region of plasma is what's causing that low GOES magnetometer reading, as we don't get very direct potential field surface source lines to the solar chromosphere. They're ending at the corona, which mitigates the amount of magnetism detectable by the GOES 16. So this data is 1 hour and 9 minutes old, folks, and you're looking at the polarity of the current sheet. So the heliospheric current sheet is charged up by the solar polar fields. Earth is currently in the South Pole-oriented one shown here in red. We'll also show you the line-of-sight view of this same data. There's that. It also shows you the solar magnetogram. And that blue line is the demarcation line between North and South Pole polarity. It gives you some insight into when the heliospheric current sheet polarity will change. And the line-of-sight coronal hole plot shows us the sun's B field in these blue potential field surface source lines. And you can see a coronal hole rotating into the Earth-facing zone here. It's South Pole-oriented. It's actually been degrading over the past couple of days as the coronal hole drought continues well into cycle 25. Here are the sunspot groups and detected filaments. Again, sunspot 2827 is a beta-class sunspot, as is 2829. Both of those sunspots have the capacity to produce significant solar flares. And there are some plasma filaments in between Earth and Sun once again. The likelihood of coronal mass ejections is still there, although not particularly high. We're not issuing a warning at this time. KP index, a measurement of global geomagnetism, currently at 3. And let's go to the real-time solar wind. Current solar wind conditions are, we've got an elevated solar wind density here. So this looks like the leading edge of a coronal hole wind stream. Solar wind density up to 20, having reached a peak of about 45 protons per cubic centimeter. Again, current conditions right around 20 protons per cubic centimeter. Solar wind speed still very low at 300 kilometers per second. Expect to see an uptick in this. Again, it looks like a coronal hole wind stream signature. So here's the magnetohydrodynamic pressure over the past 4 hours. This is our geospace magnetosphere movie. You can find these yourself on the Space Weather Prediction Center. And you see that increased magnetohydrodynamic pressure as a result of the solar wind density. Less so the speed. Expect to see the density drop down a bit and the speed come up a bit, if indeed that is a coronal hole wind stream, which it certainly does look like at the current time. Next, looking at ground magnetic perturbations. And changes in the solar wind can cause changes in geomagnetism at the surface of the planet, which is what we're looking at. And check out all the perturbations here south of South America. The South Geomagnetic Pole is someplace over here. We would expect to see most of those perturbations associated with that South Geomagnetic Pole. However, we don't. We see most of the perturbations down here, south of South America. I'll let it play through a second time as it looks quite anomalous. During this polar excursion, when Earth has two geomagnetic north poles, one over Canada and one over Siberia. This is looking at changes to Earth's B field. And a B field, folks, is the magnetic field that goes through the magnet. We showed you the suns. There's the Earth. By the way, we are also on Twitch. Although we're not streaming live today, perhaps download the mobile app. It's a great app. It will notify you when we go live. Twitch.tv/smAsho is the URL. Thanks to our YouTube subscribers as well. Again, congratulations on finding our channel, realizing that it exists. Don't forget to press the notification bell if you'd like to be informed when we actually make a video. And don't forget to press like and subscribe if you enjoy the content. Also, share with your peeps on your favorite social media. Leave us a comment. Let us know what your favorite social media is. We're all over it. We're also on BitChute. We're also counting down to the solstice. So make sure you join us for our live streams. At the moment of the solstice, we want to be the first channel to wish you a happy summer or winter if you're in the southern hemisphere. So just over 2 weeks until the longest day in the north. Also, thanks to our new Twitter subscribers, followers, whatever you call them. And thanks to Black Pill Radio. Shout out to Ken and Shane. Great video. We loved the video yesterday. Check out our own website as well, smashomash.com. Smashomash.org will redirect you. You can find our social media accounts there as well as links to our shops and the smAsho forum. And welcome to the Neo-Renaissance. Also, check out our cosmology and meteorology segments. We've put out both of those today. If you haven't checked them out, please do so. Next, thanks to our patrons. If you'd like the earliest space weather alerts of anybody in the world, as well as all kinds of other background science information, multimedia, things like ringtones, free music, and more, patreon.com/smAshomash is the place to go. We're using it to help to increase our operations. So thanks again to patrons. Patreon.com/smAshomash. There are quite a few tiers ranging from $3 to $15 per month. Patreon.com/smAshomash. Electrons in the Earth geospace can charge up satellites, and we see some satellite charging hazards right now over places like Central America and Mexico, the Central Atlantic, the Caribbean, and the Central Pacific. Here's the 1-year chart of the electron flux, and we're at pretty low levels here. We can expect to see levels remain low, especially if indeed we are seeing a coronal hole wind stream, as coronal hole wind streams are known to reduce the electron content. Here's the forecast model, and it looks like NOAA tends to agree with me as they're forecasting a dip. The forecasts are the green boxes, the yellow diamonds are the observations, and here's the total electron content forecast. I wouldn't be surprised to see rather chaotic electron belts here. You're looking at electron density for the entire air column, and this will give you an idea of your GPS error likelihood. And we are indeed seeing likely GPS errors at nighttime here. So places like the Central Atlantic, Western Africa, Northern South America, the Caribbean, and the Central Pacific, all seeing high levels of electron flux despite it being nighttime. Anyway, that's the total electron content. Here's a diagram of Earth's Van Allen belts. Feel free to pause the video. Here's another diagram of the atmosphere showing you the F-ionosphere layer, which is located at about 300 kilometers of altitude. And we've decided to change this up once again. Now we're showing 1 day of data at 2 hours per second. So this is, I think we're going to probably stay with this. Since we do daily space weather videos every day, we're showing you 1 day of the ionosphere. And we're seeing a pretty pretty irregular ionosphere here. We're seeing it vibrate down and vibrate up rather rapidly. And you can see the size of those blobs changing. Each blob here represents 1 megahertz of resolution. And there's a lot of vibration happening up there in the ionosphere, a lot of chemical reactions happening up there. It's in many ways the bridge between space and Earth. Here's the latest image at 9:15 Universal Time. We also did a great meteorology segment today. If you didn't check that out, there is a playlist for that as well. youtube.com/smAsho/playlists contains all of our playlists. And let's get into our bonus features, which will consist of the El Teide ground-based observatory. So El Teide, Spain, is looking at the sun right now in helium alpha. And there's the latest imagery, only 2 minutes and 42 seconds old. There are plasma filaments. You can see some down here. You can see some up here. And there are also some over here overlapping the edge of the solar disk. Here's some more bonus features. It's the latest refresh of the solar intensity gram and the colorized magnetogram. So here's sunspot 2827. It is still beta class, although the trailing umbrae are looking pretty weak. And here's sunspot 2829, also beta class. Trailing umbra a little stronger there, so if we're going to see major flares, I'd say they're more likely from 2829. Here are the magnetic fields. And that leading umbra on 2827 is quite large. About the size of Earth, really. And there's 2829, a little more magnetically complex. Here's sunspot 2829 and 171 angstroms. You can see a little bit of flaring. I believe that B-class flare that we showed earlier from the X-ray flux did come out of that sunspot. We didn't see a coronal mass ejection associated with this activity. That material has either stayed suspended in the corona or has splashed back down into the chromosphere area. And last but not least, here is a close-up of sunspot 2827. Thanks for tuning into the Daily Space Weather, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. I don't care if you drink, just don't drive. And since it'll never be now again, may that solar wind be at your back.